Peer pressure.
I got
Go,
it.
go. So ready to
Getting more auxiliary.
Yesterday, I sounded like
Maybe
from
it
a
is, I don't know.
pubescent boy who's a teenager who's going through.
I feel like I'm starting this.
And it's awful.
These
sound
My
so
voice
funny.
it sounds like horrible.
I didn't notice anything.
Okay.
You don't hear it?
Get out your homework. How did it go?
This is not done, right?
That was the other day.
Yeah.
What did you say, Megan?
Here we go.
I feel like it went really well. I like, I like, as long as I'm like doing, like, as long as I get the answers correct, I think that I have a really good grasp of it.
Okay, good.
I
We will
agree.
go over those just to make sure everybody is on the right
We do
track.
our homework together, so I feel like.
So all of your answers are the same?
Yeah.
Oh wow, they're having a little conversation.
Okay. Then for A, for the net force, it was 600 newtons down. The mass was 61.22 kilograms, and the acceleration was 9.8 meters per second down.
What did she say? Congratulations. Oh, I'm so sorry.
We are going over our homework. The acceleration. B, the net, was everybody good on A? Yes. B, the net force was 200 newtons down. The mass was 61.22 kilograms again. And the acceleration was 3.27 meters per second down. Good? Yes? Okay, C, the net force was 2,000 newtons left. The mass was 816.3 kilograms, and the acceleration was 2.45 meters per second left. Good. Okay, D, the net force was 4,000 newtons left. The mass was 816.3 kilograms, and the acceleration was 4.9 meters per second left. And if you notice with some of these, a lot of, like A and B, there's a lot of similarities, like the gravity is the same as for C and D. And so if you looked just in the change of the net force, like we did yesterday, if the mass is the same and the net force, in this case from C to D, is increasing by a factor of 2, then we would know that the acceleration would also just increase by a factor of 2, which it does. If you look at C was 2.45, if you multiply that by 2, you get 4.9. Make sense? E, the net force is 8 newtons right, and the mass is 2.04 kilograms, and the acceleration is 3.92 meters per second right. And F, the net force was 16 newtons right, the mass was 4.08 kilograms, and the acceleration was also 3.92 meters per second right. So who can explain to us why the acceleration is the same for E and F? Anyone? Olivia?
Like, the ratio between 8 and 2 is the same as like it is between 16 and 4.
Okay, that's a good way to look at it, because net force, remember, is directly proportional to acceleration, and mass is inversely proportional. So, good, if the ratios of the net force to the mass are the same, then the acceleration would be the same. Good, I was gonna say, the net force is multiplying by 2, so our acceleration would be multiplying by 2. But since the mass is also multiplying by 2, our acceleration would be dividing by 2, and so multiplying by 2 and then dividing by 2 would cancel each other out, so the accelerations are the same. Very good. Okay, let's look at the front side of that together. I found it to be a little tricky, so let's see what you guys think. Number 1, Luke out below drops a 5-kilogram fat cat with an approximate weight of 50 newtons off the high dive into the pool below, which on this occasion is filled with water. Upon encountering the water in the pool, the cat encounters a 50 Newton upward restraining force. Which one of the velocity time graphs best describes the motion of the cat? So, a review of velocity time graphs. If the velocity is above the time axis, what does that mean about the velocity?
It's
Going the same direction.
positive.
It's positive. And if the velocity is positive, that would mean that it's moving up. Or right, yes. And yeah, it could be up or it could be right. In this case, it would be up. And if the velocity is below the time axis, that would mean it's moving downward in the negative direction. So, what were you going to say, Lauren?
C.
You were going to say C. Okay.
Oh wait, no, I did this. I don't know. I forget now because I did this one on the practice problems, and
Oh,
I
did
remember,
you?
like,
I was thinking.
Yeah, but now I forget what one
I
it
thought it was
was.
C though.
It might
Like a
be because
Where
we're
was
speeding
that?
up
I
in
was
the air,
actually
and then
looking
it hits
for it in
the
the
water,
practice
and
problems.
it moves at a constant. Yeah, it's B. It's B.
I did it too. I was
Yeah.
like, this problem looks really familiar.
Oh, good. Do you remember where it was? Like what section?
I think it was in
I didn't.
Like Newton. Did you read section 2A on Newton's second law?
I just go to the bottom of all the sections in the practice
Yeah.
problems.
That was second. Because you said, like, on our study guide you gave us, it said, like, look at, like, the bottom of, like, lesson 1 and lesson 2. And I think it was in lesson 2.
Oh, so that was in the first, so that was when you were reviewing for your test? Oh, so that was in the first law. Okay, I was just curious. So, well, we can rule out A because why?
It's above the 10.
Because that would indicate that it's a positive velocity and it's not a positive velocity. Okay, so what are your thoughts between B and C then? It's not C? Why is it not C?
Because it's when it's falling, it's like accelerating. It's not moving at a constant speed, and then when it hits the water, that makes it move at a constant speed.
Why is it moving at a constant speed when it hits the water?
Because there's a 50 Newton upward,
There's a 50 Newton upward and
a 50 Newton downward.
a 50 Newton downward, which means that
It's balanced.
it's balanced, and so since it was already moving, it's going to stay moving at the same speed in the same direction. Okay, good. So it's B. So the description of the cat's motion would be that he's speeding up as he falls down through the air, and then after he hits the water, he remains at a constant velocity. Very good. So number 2, which one of the dot grams would best describe the motion of the falling cat? Bless you.
Okay.
A, good. What would your reasoning be for that?
It's like speeding up as it falls and then it stays constant.
Good. So it's an increasing velocity or speeding up as it falls and then constant after
you say A.
Yes. Okay, several of Luke's friends were watching the motion of the falling cat. Being physics types, they began discussing the motion and made the following comments. Indicate whether each of the comments are correct or incorrect. So once the cat hit the pool, the forces are balanced and the cat will stop. No. Instead, what happens?
Constant speed?
It remains at the constant speed, right? Right, because they did leave out, like obviously there's gonna be some other kind of force that's going to act on the cat because it's not gonna continue going down into the water indefinitely. So it's gonna eventually float back up to the surface, but we're not talking about that part. Which is why you would think it would be C, I think, the original graph, because you would think you would eventually have a zero velocity, but anyway. B, upon hitting the pool, the cat will accelerate upwards because the pool applies an upward force. Yes or no? No. Why not?
They're balanced forces?
Right, because the forces are balanced, and so there's no acceleration if the forces are balanced. Okay, good. And C, upon hitting the pool, the cat will bounce upwards due to the upward force. No, that's not gonna happen, because again, just like we said for B, the forces are balanced, and so it will just continue.
And it's not like it's a normal force.
I feel so bad for this cat.
Right.
This is death bait.
Yeah, cats don't like water.
Like how big now. It was like falling, and it was like see it falling. Have you ever seen the video of like the cat when it like hits the fan? They like put the cat is like on the fan and it starts spinning and then it hits the wall.
Oh,
It's like why do people so
do any of you have a cat?
My cat likes water.
Your cat is so
She's weird.
Like to be in the water?
Like she tipped over her water bowl she used to so she could lay in it. And she likes baths. She's weird.
That's really bizarre.
Yeah.
I gotta say.
So we have to get her a water bowl.
I have a fat cat, but it likes to drink water. It will sit like with its head in the sink. Waits me to turn on the faucet. You need it on. It doesn't work. I'll just-
My friend's cats like to drink out of the faucet. So she'll just like turn it on for them.
Wait, what's your cat's name?
Patches.
Oh.
Not very unique.
Does Zane like to play with
Yes.
Yeah.
The other day he
Sure he has fun.
he didn't want him to be laying down, I guess, so he tried to pull him up. Patches wasn't happy.
Yeah, probably.
Okay, we're gonna do more practice of those. The ones on your assignment weren't word problems, so in these you'll just have to do a little bit more figuring since you'll have to draw the free body diagram by yourself. Jake exerts a rightward force on an 89 kilogram bed to accelerate it at 0.26 meters per second squared. The bed encounters 445 newtons of friction with the wood floor. Determine the force that Jake applies to the bed. So first, just draw your free body diagram, put your forces on there, the ones that you know, and the ones that you don't know.
Really? Why is this an
You need another one.
They're all like.
Hopefully that one.
There we go.
Okay, very good. So you have the applied force that will be going to the right, the friction that will be going to the left, and then you have the normal force and the gravity force. And you already drew the free body diagram. It should look like that, which I think all of yours did. Okay, very good. So what do you have to do next in order to figure out what the net force is?
We need to figure out how much force Jake is applying.
Right. Let's go back. We know the acceleration in this case is 0.26. And we know the weight, which is 89 kilograms. So this is slightly different than the ones that we were doing because in the past we were finding the acceleration. And we used acceleration equals the net force divided by the mass, right? But in this case, we don't know the net force, but we know the acceleration and we know the mass. So we could use the other one, which is F, the net force equals acceleration times mass to calculate the net force in this case. And when you have the net force, how will you figure out what the applied force is? Right. I forget, did it say if it's slowing down or speeding up?
I think it's
Let's see. It doesn't say. Well, if the acceleration is positive, then we can say that it's moving to the right since it's positive. So, yes, so we would add it to the friction to get the applied force. You got 468? So you got the net force to be 23, right? Use the meanings of all forces to calculate. This isn't right. That's not the right answer because that's not the right kilograms. That's wrong. So yeah, I'm sure whatever you had is correct. So if the net force is 23 and the friction was 445, you added the 23 to the 4. Right, okay, good. Okay, falling skydiver with a mass of 62.8 kilograms. Parachute gear included, opens her parachute and encounters a large upward force. She initially accelerates upward at 12.5 meters per second squared. what would this large upward force be if she's releasing her parachute? Air resistance, yes, good. Which I guess it says that right here. Determine the amount of air resistance that she encounters. So first draw your free body diagram. Good.
But the air should be longer, right?
Yes, technically. The air should be longer because she's slowing. Or she's accelerating upward, yeah. Okay, so we have just the two forces. We have the air resistance that's going up and the gravity that's going down. So it should look like that. How are we going to calculate the net force here?
Acceleration times mass.
Okay, and we know the acceleration, and we know the mass, so that will give us the net force. Good. I forget what the problem is asking for us to do again.
Air resistance.
Oh, air resistance, thank you. What else are we gonna have to calculate? Well, we're also gonna have to calculate the gravity. Do you guys remember what the formula for gravity is?
F grab equals.
Something 9.8.
Yeah.
And then.
Mass.
Yes. Okay, so did you get the net force to be what?
785.
Good. So the net force is 785. So did you calculate the gravity force? Yes, so how are we going to figure out the air resistance?
Do you subtract from each other?
Right, because if you have, what did you guys get for gravity?
615 plus 44.
I'm trusting you on that, is that what you all got? Okay. And then the air resistance, we don't know. But we know that the sum of the forces is whatever, your net force, or 785. So the net force would equal the air resistance minus the gravity. Right? Which would be what?
169.56. Yes. Oh, you're adding it? No.
Because
Well,
it's
they
like-
wrote it down slightly different than I did. They wrote the air force equals gravity plus net.
Yes, I got that. Look, subtraction.
Yes? Good. Okay. The stage crew applies a rightward force to accelerate the 215 kilogram desk. Across the stage at 1.32 meters per second squared. The coefficient of friction between the desk and the stage is 0.651. That's the mu, which is unitless. Determine the force applied to the dust. So you're trying to find the applied. Okay, so you should have 4 forces on your free body diagram. You should have gravity going down, normal going up, friction going left, and applied going to the right. So what can we assume about gravity and the normal force? We can assume that those are balanced. The thing is, we need to figure out the friction. Right? In order to figure out what the applied is. And so, what's the formula for friction? Somebody check me on that in your notes. I believe it's mu times the normal force. So how do we find what? Well, would anyone else like to take a stab at that question? You have to find gravity first, because gravity and the normal force would be equal.
Did you show us that equation?
I think it was in your notes from
Yeah.
yesterday. You not seeing it? I'm pretty sure it's right, but I just. Yes, that's right.
Oh, yeah, just found it.
You found it.
That's correct.